I'm going to do a quick probability video here. I actually did this problem today in class, and I messed it up. I did it wrong in front of the whole class, and at the end, I knew I did it wrong, but it was too late to fix it. So I'll fix it tomorrow, but I want to talk about it anyway. The mistake I made is the same mistake I always make in probability, and that is there's often multiple conditions that will satisfy a question, and I usually, if you make a mistake, you don't set up all of those conditions. So this was the problem. It says each time Christina throws a ball at a target, the probability she hits the target is 1/3. Okay, she throws the ball 3 times. We have to find the probability that she hits the target first 3 times. Well, so if there's a 1/3 probability that she hits the target 1 time, well, that would be the first throw, this would be the second throw, and that would be the third throw. So that would be 1/27. That part's not too bad. Part 2 says, what's the probability she hits the target at least once? Now, I'm going to show you it's kind of the straightforward way of doing the problem, and then you could also do the problem backwards, and doing it backwards turns out is much simpler. Anyway, so at least once is often confusing because that means she could hit the target 1 time, or she could hit the target 2 times, or she could hit the target 3 times. Those would all be at least once. We already know the probability of her hitting it 3 times is 1/27. Now, the probability that she hits it only once, though, sorry, I might have misspoke. The probability that she hits the target at least once. So look, she could hit it on her first try, which would be 1/3 times 2/3 squared. The reason it's 2/3 squared is because there are 2 other throws. This could happen in 3 ways. Plus, it could be like she could miss the first time, hit the second time, miss the third, or she could miss the first 2 and hit the third. So the reason I did it like this, it's just a little quicker, but I decided to go ahead and write it out. So like this would be a miss, a hit, and a hit. Or it could be a miss, miss, and a hit. So anyway, you have 3 of these. So this is 4/27, and we have 3. We have 1, 2, 3. They're all 4/27. There are 3. So that really becomes 12/27. That's the probability of getting 1 hit. All right. Now, the probability of getting 2 hits. So she could get 2 hits. There's 3 ways it could happen. So she could miss the first time and hit the second 2. Or is adding, she could get like if I were to write it out, it would look like this. This would be the second throw being the miss. Or she could get the third one, would be the miss. Now, these are all 3. They all equal the same thing, but I wrote them out to try to show you that, like this is the first one being a miss, the second 2 being a hit. This is the first one being a hit, the second one being a miss, and then the hit again, so 2 hits. Or the first 2 are hits and the third one is a miss. Okay? So this is 2/27 plus 2/27 plus 2/27. That makes 6/27 plus 1/27 for the 3 hits. So anyway, if you add all these up, that's 18, that's 19/27 would be the probability that you get at least 1 hit. That's very complicated, it's very ugly, it's difficult to do. If you do the problem backwards, though, it's pretty easy. The probability of not getting at least 1 hit. So that would mean all 3 are misses. So that would be 2/3 times 2/3 times 2/3, which is 8/27. That's 0 hits. The opposite of 0 hits is getting 1 hit, so the 2 of them have to add up. So to 1, the two possibilities. All of the possibilities have to add up to 1. So if you were to do this, you also get 19 over 27, and that is much simpler. Either way, though, you get the same answer. The mistake I made, and it's a mistake I often make, is I didn't set up all of the possible ways to get 1 hit and all of the possible ways to get 2 hits. Anyway, hope this helps.